What are common denominators? Well, it's when the bottom numbers of two fractions are the same. This must happen in order to add or subtract them. If you look here, we have 1 6 plus 4 6. They have them. The bottom numbers are the same, so now we can just add the top, whereas a half plus 1/3, they do not. The 2 and 3 are different, so we would need to change them before we could go ahead and add. So how can we find them? So one way is you can list them. So if you look here, I picked a fraction that a lot of people are familiar with. So we have 1/2, then it's 2/4, and 3/6. All of these mean the same. They all mean half. So the next thing is, do you see any patterns? If you look at the numerators, the top numbers, you can see a pattern starting 1, 2, 3. So it looks like the next numbers would be 4, 5, 6. And then look down below here with the denominators. We go 2, 4, 6. They're counting by 2, so the next denominator would be 8, then 10, then 12. Now I added another fraction. You could see I had 1/3. 1/3 is the same as 2 6, 3 9ths, and if I continue my pattern here, it looks like it would go 4, 5, 6 on top. And now on the bottom, I'm counting by 3, so after 9, we get a 12, then a 15, then an 18. So our first step would be to list several. These are called equivalent fractions. These are all equal. Now if you go back to that question I had on the first slide, 1/2 plus 1/3, I mentioned they did not have a common denominator. The bottom numbers weren't the same. So now we can go through our list quickly and look, when do they have the same one? Here they have the same, so we could use these numbers, or we could use these. So we could do, now we have 3 6 plus 2 6 give us 5 6, or if we wanted to or needed to, we could also use 6 12s plus 4 12s is 10 12s. Now my tip for you is you always want to use the smallest numbers, the smallest fractions you can. So in this case, I would have to put a star beside this one. That way, once we're done our answer, we don't have to come back and do what we call simplifying, which means get our fraction to the smallest possible numbers to represent our answer. Now let's take a look at some of these fractions and see how exactly did we get there. How do we make 1/2 into 2/4? And this is the most crucial part. We multiplied the bottom by 2. We also multiplied the top by the same. The way I like to describe this is you have to be fair. Whatever you do to the bottom, you do to the top, and your number will be the same. You look over here, 1 times 3, 2 times 3. That's how we turn 1/2 to 3 6. Times 4 times 4. Then we do times 5 times 5. Times 6 times 6. And then times 7 times 7. Another way to explain how I just multiplied times 2 times 2 times 3 times 3, some people explain that as the big 1. And that is why my fraction is still the same. As long as you do the same thing to the top and the bottom, it's like multiplying it by 1. Because 6 over 6 is 1. 7 over 7, 1. 131 over 131 still equals 1. So as long as whatever you do to the top number, you do to the bottom number, it is okay, and you will have you can find common denominators, and you'll have equivalent fractions. All right, now I have two fractions here for you to try. So why don't you go ahead and hit pause and see what you come up with for 3 7ths and 4 9ths, and see if you can continue this pattern, and then hit play and see how your answers compare to mine. All right, let's take a look what you came up with for 3 7ths. Now what I did, I even showed what I multiplied by. From 3 7ths, I went to 6 14ths. I did that by multiplying 2 times 2 on top and times 2 on the bottom. Then I went to 9 over 21. I went back to my 3 7ths times the top and bottom by 3's, and then I went back to the 3 7ths for my final fraction, multiply them by 4's, and got 12 over 28. Now my second fraction, we have 4 9ths. You can see I went through. It went to 8/18, 12/27, and 16/36. Now let's take what we learned about finding common denominators and apply it to this subtraction problem. So we have 6/7, so we're going to list some equivalent fractions, and then 1/3 we're going to do the same and look for common denominators. So we go 6/7. I took liberty to go ahead and finish my list, and you can see we finally got ourselves a common denominator with 18/21 minus 7/21. Now that our bottom numbers are the same, or we have common denominators, we can just subtract numerators. We get 11, bottom number stays the same, and our answer is 11/21. I listed some equivalent fractions here for both 3/5 and 1/4, and as you can see, I've found a match where our common denominator is going to be 20. Once we have the common denominator, we can go ahead and set up our math problem. So it's now 12/20 plus 5/20. Add the numerators, 17. Bottom number stays the same. And again, we have 17/20. And to wrap up this video, just in case you forgot how to do traditional multiplication, I'm going to go ahead and remind you. So we are focusing our attention just on the ones place. We're kind of ignoring that 4 right now, and we will just kind of follow this pattern here. All right, 3 times 2 is 6. Then we go 2 times 7 is 14. The 1s goes down. The 10s gets carried over. 2 times 4 is 8 plus 1 is 9. Next, now we get to ignore the 2. Whenever you move down to that second line, you can put a 0 or an X, or both. And then we do 4 times 3, which is 12, carry the 1. 4 times 7 is 28, plus 1 more is 29. And 4 times 4 is 16, plus 2, which is 18. If we did this correctly, we should be able to add quite easily and get our answer of 19,866. One thing to keep an eye out for, it sounds kind of silly, but I see it happen all the time. After a whole lot of multiplying, be careful you do not multiply down here at the bottom when it's time to add. One other thing that we could do just to see how our answer compares, we could do an estimate. We can do 473 is 500 times 42 would be 40. 5 times 4 is 20. Count up my zeros, 1, 2, 3. And my estimate goes right along with my answer of that 19,866. Hope this helps.